All right, so what we're going to talk about is another form of a quadratic function, which is going to be vertex form. So the first thing we're going to do is I want you to write really, really big on your paper, okay? I want it to go all the way across the page, and I want you to take up about 3 or 4 lines when you're writing this, because this is going to be the most important part of your notes, is going to be this part. So vertex form looks like this, plus or minus some a value, okay? And it's going to say quantity x minus h squared plus k. And the first thing that we're going to talk about is what all of these different pieces in this form, what those tell you about the graph. And so we're going to go back and forth between the calculator. And so the first thing I'm going to do is let's pull up our calculator and let's go into y equals x squared. Now again, this calculator is a little bit different than yours, but it'll still do a good enough job giving us the general idea. So this is what y equals x squared looks like. This is what's called the parent function. It's the most basic parabola in this family of parabola functions. Okay, well what I want to do is I want to go into y2 and I'm going to type in y equals negative x squared. You can either watch or you can do this with me, but I just want to visualize what these transformations are doing. And what we see right here is that the graph has been, it now opens upside down. But what the transformation is called is what we're doing is reflecting the parabola across the x-axis. And so that's the way that we need to talk about this transformation. Rather than saying the graph opens down, what we say here is that this plus or minus is an x-axis reflection. Okay, and you only have an x-axis reflection if the a value is less than 0. If the a value is positive, then I would just simply say that there is no reflection. Okay, so let's go ahead and go back to our calculator and let's talk a little bit more about what this a value is doing. So I'm going to leave y equals x squared. Let's change y2 to be 3x squared. And let's take a look at what that does. Well, you can see in black right here, this black parabola is 3x squared, that the parabola is a little bit more narrow. Okay, well, I'm going to come down to y3, and I'm going to type in 1/8 x squared. And when I hit graph, you can see in red that this parabola is more wide. So we already knew that the A was affecting the opening of the graph, but what we need to add to it is that it also affects the width of the graph. And what we call this is a vertical stretch or shrink. Okay, so if the A value is greater than 1, this is a vertical stretch, and it's going to make the graph more narrow because we're taking the graph and stretching it vertically. If the A value is between 0 and 1, it's a vertical shrink, like we saw in our calculator with that parabola that was a little bit more wide. We're compressing or shrinking the parabola vertically, which makes it look a little bit more wide. And so that is our rules right here for a vertical stretch or shrink. Now, I do want you to notice that I did say that a shrink was when A is between 0 and 1, because if your A is negative, remember, that means that it's an x-axis reflection. So those are actually 2 separate transformations. All right, let's go back into our calculator, and I'm going to clear out everything except for our y1. This time, let's open up a parenthesis, and inside this quantity, okay, I'm going to put x minus 4. I'm going to hit graph. Let's take a look at what happens. And what we see here with this new black parabola is that it's been shifted. Now this calculator does not do as good of a job of showing you how many units, so I'm going to go ahead and tell you that this has been shifted to the right 4 units. Well, what would happen if I changed it to a plus 4? Let's take a look, and this is going to appear in red. Well, what happens is it's going to shift it to the left. What I want you to also notice about this is not only is it shifting the parabola left and right, but it's actually moving our vertex, okay, where before our vertex was staying the same. And so what this piece right here does is this is the horizontal shift. It's moving the parabola left and right. Okay, now here's where we need to be careful, because if it looks like x minus h squared, it actually shifts to the right h units. And if it is x plus h squared, it shifts to the left h units. Okay, so it almost in a way does the opposite of what we think it should do, so we need to be careful when we're interpreting that right there. All right, finally, we have our last transformation, and this would be if I take a parabola, I'm going to clear everything out. If I take a parabola and maybe I take x squared and I just add 3 to it, okay? Well, what you're going to see is that the parabola is shifted up 3 units. Well, same thing, if I take x squared and I subtract 5, okay, this parabola is going to be in red, then what we're going to see is that the parabola is shifting down 5 units. So this last piece, this is going to be the vertical shift. I'm running out of room a little bit, but I think I can get this to squeeze. This is the vertical shift. If it's plus k, it's going to be up k units. And if it's minus k, it's going to move down k units. So this one's a little bit more straightforward. It does what it looks like it should do. All right, so there is all of our transformations written out. Now, what I will also want to note are, what were the 2 transformations that affected the vertex? And the 2 transformations that affect the vertex are these 2. The vertex of a parabola is affected when you shift it left and right and when you shift a parabola up and down. The vertex is what we're going to call HK, okay? It's this coordinate is the x coordinate of the vertex, and this number is the y coordinate of the vertex. So I actually want to talk real quick about a homework problem. When we were talking about number 10, it looked like -3 x minus 1 squared plus 2. And the problem said to what would be the coordinates of the vertex if it's reflected across the x-axis and left 5. Well, what you probably did is you probably wrote this problem out in standard form to figure out the vertex. Well, what I want you to now notice about this is that the vertex is actually we can see it because it's in vertex form. The x coordinate of the vertex is going to be +1 because remember, x minus 1 squared means we move right 1 unit. And the y coordinate of the vertex is 2 because this means it moves up 2 units. And so that makes things a little bit easier when we can just go ahead and pull out the vertex rather than having to use the little formula. So the last thing that I want to do in these notes, we're going to talk more about the graphing in class. Because it's a little bit easier to hear that in person. But what we're going to do to finish up these notes is let's do an example of how we could write a quadratic function in vertex form. So let's write a quadratic function in vertex form. Okay, that has a vertex -2, -5, such that f of 4 is equal to 22. All right. Well, they already kind of told us to write it in vertex form, but I am going to tell you down the road, they may not always say what form to write it in. So based on the fact that I was given a vertex, that would be my clue that I'm going to start with vertex form, which is this right here, if you want to put this on your paper. The first thing I want you to do is I want you to plug in the given vertex. Leave this a value out in front, okay? If you don't put the a value, then you're making an incorrect assumption that the a value is 1, which it is not. And so it's going to go x minus, and when we substitute in the h value, which is right here, we're going to be plugging in a -2. And so we can see right here that when we take x minus -2, what's going to happen to minus the negative, which we will then fix in our next step, but you are correct, it's going to turn into a plus. Now the k value is going to be substituted in, right here is the k, and I'm just going to write -5. Okay, so let's fix this up a little bit. Again, I don't want to leave this as minus and negative, but that is why right there, that if your vertex is a -2, when you plug it into the formula and take x minus -2, that's why it appears to be a +2. So you're going to plug in the vertex. I'm going to put this in words. Plug in the vertex. Well, now what I want to do is I just want to illustrate over here. I'm going to sketch a parabola that has a vertex at -2, -5. Okay, let's just suppose this was -2, -5. How many parabolas have a vertex at -2, -5, right? I'm just going to start sketching out a few parabolas and hoping that you can eventually, when I ask the question again, how many parabolas have a vertex at -2, -5? The answer is there's an infinite number of parabolas. But how many parabolas have a vertex at -2, -5 and pass through the point 422? Well, the answer to that is easy. There's one parabola that passes through this given point, and it's the A value that gives the parabola that perfect width to be able to pass through the given point. So what we need to do is plug in the given point, okay, which in function notation, remember, is the point 422. We're going to plug in the given point for x and y. The whole goal is to solve for a. All right, so if I plug in 22 for y, you know what, just to give myself some space here, I'm going to go ahead and get rid of this. This was just more for a visual for you. All right, so 22 gets plugged in for y. I'm going to plug in 4 for x, and what we're going to do now is we're going to solve for a. 22 equals a. Let's go ahead and start with the parentheses. I'm going to go ahead and work through my exponents, and we're going to get 36a minus 5. Add 5 to both sides, 27 equals 36a. And we divide both sides by 36 and reduce it. Your a value is going to equal, right? If we think about dividing this by 9 and this by 9, the a value is going to equal 3/4. And so our final equation in vertex form is 3/4, okay? We almost have it written up here, x plus 2 squared minus 5. So that's the basics of, let's kind of run back through what we just talked about. Oh, sorry about that. Go ahead and write that down. So what the basics of what we just talked about was what vertex form looks like, what all the different pieces of vertex form tell you about the way that the parabola has been transformed. And then finally, we did an example of given a vertex and a point, we can write an equation in vertex form. We'll pick up in class on how to graph